guys, welcome back to another tutorial. I'm your tutor, Disha. Today we're going to be talking about a relatively difficult topic in mathematics, functions. Now I've realized when some of my students encounter the topic of functions, they just can't function. But today I'm going to teach you how to functuate functions. Stay tuned. What is a function? Let's start with an example. You use your TV remote to input to Netflix that you want to watch a particular movie. Netflix then uses this information to match it to specific movies before narrowing it down to the one you request. We can use this same analogy to define the term function. Hence, a function is a relation from a set of inputs to a possible set of outputs, where each input is directly related to one output. Now, a function is normally written as f of x, where x is the input value. Now, let's push all of that theory aside and start working examples. Now, given the function f of x, it looks like f is being multiplied by x. Not so. It is showing that f is a function of x. We are literally going to input values into x to output their corresponding values according to the function given. Okay guys, let's do an example together. Given the following linear function, and linear functions are those whose graph is a straight line. F of x is equal to 3x plus 2. We're literally inputting into the function the values of x, then multiplying them by 3 and add 2 to it. Let's do an example together. We're going to input 2 into the function. This will leave us having 3 multiplied by 2 plus 2. 3, 2, 6 plus 2 is 8. Let's try with 4. 3 4s 12 plus 2, 14. Now let's do another example. Given the function f of x is equal to x squared, we're literally going to input these values here into the function and squaring them. So we're inputting 3 into the function. The square of 3 is 9. We're inputting minus 6 into the function. Negative times negative is positive, so that's 36. We're inputting 9 into the function. The square of 9 is 81. Given the function f of x is equal to x cubed minus x, we're literally inputting these values into the functions and subtracting it from the same values. That's what the function is saying. So we have 5. Now 5 cubed is 125 minus 5 is equal to 120. Now given 6, inputting 6 here, 6 times 6 times 6, we should arrive at 216. 216 minus 6 is equal to 110. And these would be the output for the inputted values here. Now let's take a step up in functions. We're going to be talking about composite functions, aka function of a function. Composite functions are made when one function is substituted into another. Let us look at the following functions. F of x is equal to 3x plus 2. I'm going to call this 1. Let us look at the second function. G of x is equal to x plus 5. I'm going to call this 2. To find f of g of x, we're literally going to input the value of g into x. This was the original function of f, 3x plus 2. Inputting g would give us 3x plus 5, as g was x plus 5. This would give us 3 times x, 3x plus 3 times 15, 15 plus 2. This results in 3x plus 17. Now suppose we wanted to find the opposite of this composite function. All we needed to do is to do the reverse. G of f of x. Inputting the value of f into g is all we need to do. So g is equal to 3x plus 2 plus 5. This would be equal to 3x plus 7. Let's do another example, guys. Given the function f of x is equal to 4x minus 2 and g of x is equal to 3x minus 1, we're going to find f of g of x. Remember, we're going to input the value of g into the function of x. So this would be 4 into g minus 2. So 4 into 3x minus 1 minus 2. 4 3s 12x, 4 1s 4, minus 2. So the answer is 12x minus 6. Suppose we wanted to reverse this by saying g of x. All we need to do is to input the value of f into the function g. This will give us 3 into 4x minus 2 minus 1. 3 4s 12x minus 3 2s 6 minus 1 12x minus 7. Okay guys, so now we are going to step up again in the topic of functions. We're going to be looking at the inverse of a function. Now, an inverse of a function occurs when one function reverses another function, or interchanging them to the output to the input. Now, given the function f of x is equal to 6x minus 2, we're going to find the inverse of x by literally switching it. Find the inverse of a function. Let us look at my first example. Given that f of x is equal to 6x minus 2, find the inverse. This little f minus 1 means inverse of x. Guys, we're literally switching them around. Recall from my first example, my very first example using functions, I mapped the input, which was x, to the output, which was y. To find the inverse, all we're doing is rearranging it. So we're going to map the output, which is y, to the input, which is x. Now, since we rewrote our function as y equals 6x minus 2, the first thing we're going to do is to interchange the variables. Interchange y and with x. This would give x is equal to 6y minus 2. So the next thing we're going to do is to solve for y. So step 2, solve for y. We do this by adding 2 to both sides. This will give us x plus 2 is equal to 6y. We already had a minus 2 there, so adding 2 to it would give us 0. So our new function is x plus 2 is equal to 6y. Continue solving for y. We need to divide both sides of the equation by 6. Let's do that. Over 6 over 6. This will cancel out and our new function would be x plus 2 divided by 6 is equal to y. Now this was the result of solving for y. But looking at this equation, I realized that it can be simplified more. So 2 into 2, 1, 2 into 6, 3. Hence, I will arrive at x plus 1 over 3 is equal to y. Plus 1 divided by 3 is equal to y. I noticed that it cannot be simplified any further. So the next thing that I do is I rewrite my inverse of a function. So the inverse of x is equal to x plus 1 over 3. Let us recall the steps in what we use to find the inverse of a function. Step 1, we rewrote the equation using y. Step 2, we interchange the variables. Step 3, we solve for y. Okay guys, thanks for watching part 1 of functions. Stay tuned for part 2 where we'll be taking another step in looking at functions. Remember to like, share, and subscribe to Disha's Tutoring. Bye!